Welcome to the final episode in our Design Patterns in Java series. We've explored a wide range of creational, structural, and behavioral patterns, and today we wrap up with one of the most flexible behavioral patterns, the strategy pattern. This pattern empowers your code to select an algorithm at runtime without changing the client logic. It's especially useful when you have multiple ways to perform a task, such as sorting, filtering, formatting, or compressing, and you want to swap those behaviors without modifying the core business logic. The strategy pattern defines a family of algorithms, encapsulates each one, and makes them interchangeable. The context class delegates the algorithm execution to a strategy interface, allowing the behavior to vary independently from the clients that use it. This pattern is a powerful alternative to using conditional logic, if or switch statements, like some of those, to choose between different algorithms. So what are the use cases actually to use the strategy pattern? Well, sorting lists with different strategies, quick sort, merge sort, or bubble sort, payment processing like credit card, PayPal, crypto, or whatever, data compression using zip, rar, or tar, logging strategies like files, database, cloud, or input validation, different formats or locale rules. So for this example, we're going to use a text formatter with the strategy pattern. We'll build a text editor class that delegates formatting logic to a strategy. This allows us to plug in different formatters like plain text, HTML, or Markdown at runtime. So let's dive into the code, and for that I need to be small. So let's go and have a look at this beautiful code. So first of all, we have created a text formatter interface, and let me click on that. So we have a text formatter interface. The text formatter interface defines the contract for all the strategies. Each formatter will implement this and define its specific formatting behavior. So we have some concrete strategies, and let's go over them. We have a plain text formatter, which just returns the text. We have a Markdown formatter, which just renders it at Markdown. And we have an HTML text formatter, which formats it to HTML. So that's all very simple. Each implementation actually handles formatting differently, but they all conform to the same text formatter interface. This makes them completely interchangeable. And now we go to the text editor. Now, the text editor is a bit more complex, right? As you can see right here, there's a bit more code than just some rendering stuff going on. The text editor holds a reference to a strategy and delegates formatting to it. So it doesn't do any of the formatting itself. It just says, I have this strategy and you go and do it. The editor doesn't care how the formatting is done. It just calls the format method. The separation of concerns makes it easy to add new formatting behaviors without touching the text editor code. So this is what it does, right? We have a set formatter, and the set formatter just says, I accept anything that adheres to the text formatter interface, right? So let's go to the text editor again. It just says, this is the formatter. So we have a setter method for that. So we can change the strategy. The strategy is the text formatter. And then it has a method that you can call publish text. Now it checks like if the formatter is null, then I don't have a formatter. So it does need to have a formatter. It checks it here. Otherwise, it just prints whatever the formatter returns in its format method. So depending on the strategy that we choose, it returns something else. It could return plain text, Markdown, or HTML, whatever your heart desires. So let's look at it right here. We have created a new text editor instance editor, and we have a couple ways to render some beautiful text. So we have the plain text formatter, the HTML text formatter, and the Markdown formatter. And now look at this. This is all done at runtime because we have created a set formatter method, which changes the strategy so you can render HTML or Markdown or plain text, and you don't have to touch your code ever. You can just do all of that in runtime. Let's run it real quick. And you see how it works, right? So we have the same editor instance. And at first we set it to plain text. So it just creates plain text. Simple, right? Then we set our strategy or our formatter to a HTML text formatter, which, well, as the name kind of suggests, returns HTML. And the same for the Markdown one, that returns Markdown stuff. Amazing, right? We've now actually implemented the strategy pattern, and it wasn't that complex to begin with, because all you do is, this is your strategy, you create a set formatter or a set strategy, however you want to call it, whatever you are doing, depending on your domain. And then you just call the methods on there to do whatever they need to do. And bam, you now have used the strategy pattern and you can change everything at runtime. Amazing. So what actually are the benefits of this pattern? And the benefits are, it promotes the open-closed principle. New algorithms can be added without changing existing code. It eliminates messy conditionals and switch statements. It encourages separations of concern between behavior and client logic, and it makes algorithms independently testable and reusable. While there also are some limitations, it can result in many small classes, requires clients to understand and choose the appropriate strategy, or sometimes it's just overkill for simple behaviors or when only one strategy is used. If you use one strategy, you don't need the strategy pattern. All right. Now we also have some best practices. Best practices: keep strategies stateless unless needed. Use interfaces instead of abstract classes for maximum flexibility. Inject strategies via setters, constructors, or dependency injection frameworks, and combine with other patterns like factory or decorator to create very powerful systems. And now we have a small recap. In this episode, we explored the strategy pattern, a behavioral pattern that enables flexible and interchangeable algorithms. We implemented a text editor that could delegate formatting to different strategies on the fly. This pattern is especially useful when you anticipate changing behavior over time or when behavior varies based on runtime decisions. Thanks for following this series. If you enjoyed it, consider subscribing, leaving some feedback in the comments, or sharing this playlist with others who want to learn clean, extensible software design in Java. Thank you for watching all the way through. I hope you have learned something very valuable and your team or you yourself can now be proud of the code that you'll be able to write. Happy coding, and I'll see you in the next playlist.